Section 12.8 is applications with variation. There will be three main types of variation problems that we will do in this section. What I like about section 12.8 is they are the most direct word problems you will actually ever do, because it's very specific about which formula you use. So there's not a lot of guessing and trying to figure out which formula you use. It will tell you which formula to use. The other thing that I want you to know is that these formulas are on your formula sheet, so they are not something that you have to memorize. I know that's always a concern some students have. Never fear, no memorization is necessary for these. The first type of application problem involving variation are direct variation equations. You'll see these worded similar to these first two bullets. Y varies directly as x, y is directly proportional to x, and the formula for a direct variation equation is y equals kx, where k is your constant of variation. Inverse variation problems could be stated y varies inversely as x, or y is inversely proportional to x. And the formula for inverse variation is y equals k over x, again, where k is your constant of variation. Joint variation problems will say z varies jointly as x and y. The formula for joint variation problems are z equals kxy, k being your constant of variation once again. And then there are times where you'll have a situation where they use a combination of variations. For example, z varies directly to x and inversely to y. The formula for that statement would be z equals kx over y, where k is again your constant of variation. The steps to solving these problems involve first finding the k value, that constant of variation. So you'll find k using the correct formula and the given values. You're going to have to write a formula, and then it will give you values for all of the variables except k, so you can solve for k. Step 2 will be to rewrite your equation and replace k with the value in step 1. If we look at the combination variation formula, for example, let's say k equals 12 in that situation. When I write my formula for step 2, it would be z equals 12x over y. When you rewrite your formula, the only variable that is going to be replaced by a number initially will be the k value. And step 3, plug in the values given and solve for the missing variable. Example number 1, if y is directly proportional to x and y equals 33 when x equals 42, find y if x equals 13. Step 1 will be writing the formula. Y is directly proportional to x. Y equals kx. Finding our value for k, we're going to plug 33 in for y, 42 in for x. Divide both sides by 42. K equals 33 over 42. If you would like to, you can reduce that if it's a fraction that can be reduced, or you can leave it as is. That is entirely up to you. 3 will go into both of those. 3 divides into 33 11 times. 3 divides into 42 14 times. Step 2, we will rewrite our formula. And I leave mine as a fraction. Y equals, instead of k, I'm going to put in the value I found for that, 11 over 14 x. Step 3, we're going to solve for the variable. We are going to look for y when we know x is 13. Y equals 11 over 14 times 13 for x. What I did forget to tell you is the directions here, unless otherwise stated, is to round all answers to the nearest hundredth. I highly recommend having a calculator. These are going to be problems that you're going to want to use a calculator for. When I take 11 over 14 times 13, I end up with 10.21. Y equals 10.21. Example 2, if y is inversely proportional to x and y equals 53 when x equals 27, find y if x is 9. Our first step, find that constant of variation. Y equals, so y is inversely proportional, that's k over x. I'm going to replace y with 53. 53 equals k over x is 27. Multiply both sides times 27. My k value is 1,431. Step 2 is to rewrite my formula using my k value. Y equals 1,431 over x. Step 3, I'm going to replace x with 9 and figure out what y is. That gives me y equals 1,431 divided by 9. Y equals 159. Example 3, if y is directly proportional to x squared and y equals 299 when x equals 3, find y if x equals 11. Step 1, y is directly proportional, so that's k, to x squared. Directly proportional to x squared gives me y equals kx squared. I'm going to replace y with 299 equals, k stays k, x gets replaced with 3, so I have 3 squared. I'm going to divide both sides by 9. K equals 299 over 9. Step 2 will be to rewrite our formula. Y equals 299 over 9, x squared. Step 3, I'm going to find y when x is 11. Y equals 299 over 9 times 11 squared is 299 over 9 times 121. Y equals 4,019.89. Step 4, if y is inversely proportional to x cubed and y equals 12 when x equals 3, find y if x equals 6. Step 1, y equals k over x cubed. Y is inversely proportional to x cubed. I'm going to replace y with 12. 12 equals k over, replace x with 3, k over 3 cubed. Multiply both sides times 27. K equals 324. Step 2, rewrite my formula. Y equals 324 over x to the third. Step 3, find y if x is equal to 6. That's y equals 324 divided by 6 to the third. Y equals 1.50. Example 5, z is jointly proportional to x cubed and y squared. If z equals 299 when x equals 2 and y equals 2, find z when x equals 5 and y equals 6. Step 1, z equals kx cubed y squared. That's Z is jointly proportional to x cubed and y squared. Z equals k x cubed y squared. I'm going to replace z with 299. 299 equals k times x is 2 to the third, y is 2 to the second. 299 equals k times 2 to the fifth. Divide both sides by 2 to the fifth, which is 32. K is equal to 299 over 32. Step 2 is to write my formula. Z equals 299 over 32 x cubed y squared. Step 3, find z when x is 5 and y is 6. Z equals 299 over 32 times 5 to the third times 6 squared. Z is equal to 42,046.88. Starting to see why you need a calculator? Example 6, z varies directly as x squared and inversely as y squared. If z equals 248 when x equals 8 and y equals 9, find z if x equals 5 and y equals 5. Step 1, write my formula. Z equals kx squared over y squared. Z varies directly with as x squared. Z equals kx squared and inversely is y squared. So kx squared over y squared. I'm going to replace z with 248 equals k times x is 8 squared, and y is 9. So I have 9 squared. I'm going to multiply both sides times 81 over 64. K equals 1,984 over 64. I'm sure I could reduce that, but I'm not going to take the time because I have a calculator. Step 2, rewrite the formula. Z equals 1,984 over 64 x squared over y squared. Step 3, z equals 1,984 over 64 times x squared is 5 squared over y squared, which is 5 squared. This one is nice because the 5 squareds divide out, and that leaves me with z equals 313.88 because it's simply 1,984 divided by 64. Example 7 is an application problem that isn't just telling you which type of variation you're going to use. It isn't direct, quite like the problems that we did before, but it is still direct if you read it. Example 7, the distance that a free-falling object falls is directly proportional to the square of the time it falls before it hits the ground. If an object fell 77 feet in 5 seconds, how far will it have fallen by the end of 9 seconds? Leave the variation constant in fraction form or round to at least 2 decimal places. Round your final answer to the nearest foot. Remember, I always keep my k as a fraction. It makes your answer more accurate. The distance that a free-falling object falls is directly proportional to the square of the time it falls. I'm going to use d for distance. Varies directly means k times something. In this case, the square of time, which will be t squared. That's my formula. I know that if an object fell 77 feet, replace d with 77. It took 5 seconds. Replace t with 5, which will be 5 squared. So my constant of variation is 77 over 25. D equals 77 over 25 times T squared. I want to know now how far it has fallen at the end of 9 seconds. So 77 over 25 times 9 squared gives me 249.48. I need to round to my nearest foot, which is 249 feet. Example 8, the volume of gas in a container varies inversely as the pressure on the gas. If a gas has a volume of 360 cubic inches under a pressure of 19 pounds per square inch, what will be its volume if the pressure is increased to 20 pounds per square inch? Round your answers to the nearest cubic inch. Volume, I'm going to call that V, of gas in a container varies inversely as the pressure. V equals K over P. A gas has a volume of 360 cubic inches. 360 equals K over, the pressure is 19 pounds per square inch. So K over 19, multiply both sides by 19. K is equal to 6,480. Volume equals 6,480 divided by pressure. This time I increase my pressure to 20 pounds per square inch. My volume is equal to 6,480 divided by 20. So my volume is 324 cubic inches. Example 9, the length that hanging spring stretches varies directly as the weight placed at the end of its diameter. If a weight of 31 pounds stretches a certain spring 13 inches, how far will the spring stretch if the weight is increased to 48 pounds? Leave the variation constant in fraction form. Round off your final answer to the nearest inch. Length that a hanging spring stretches varies directly as the weight placed at the end of its diameter. L equals KW. If a 31-pound weight, so K times 31, stretches a certain spring 13 inches, so 13 goes where the L is, 13 equals K times 31. Divide both sides by 31. My constant of variation is 13 over 31. So my formula is length equals 13 over 31 times W. This time my weight is 48 pounds. So the length equals 13 over 31 times 48. My length is 20.12, which gives me to the nearest inch 20 inches. Here's our final example. Example 10, the resistance R of a wire varies directly as its length and inversely as the square of its diameter. If the resistance of a wire 4,600 feet long with a diameter of 0.31 inches is 12,698 ohms, what is the resistance of 4,800 feet of the same type of wire with a diameter of 0.48 inches? Leave K in fraction form or round to at least 3 decimal places. Round off your final answer to the nearest hundredth. R, which is resistance of a wire, varies directly. K as its length, so L, and inversely as the square of its diameter, over D squared. My formula is R equals KL over D squared. The resistance of a wire varies directly as its length and inversely as the square of its diameter. The resistance is 12,698 when the length is 4,600 feet and the diameter is 0.31 inches squared. My value for K is 12,698 times 0.31 squared over 4,600. I'm not simplifying anything. I'm leaving it just like that. We will do all the simplifying at the end when we use our calculator to find our answer. So my formula are equals 12,698 times 0.31 squared over 4,600, all that times L over D squared. For this particular problem, that's 12,698 times 0.31 squared over 4,600 times a length of 4,800 feet when the diameter is 0.48 squared. So my resistance is 6,288.07 ohms.